is specific to that particular model and brand of video chipset. Are we doing okay so far? Okay. As a result, it is practically impossible for any operating system to know how to make use of all available peripherals hardware components. So remember, I'm not talking about installed peripheral hardware components. I'm talking about available hardware components, because if you just look at the entire history of, say, NVIDIA, how many different chipsets have they invented or developed?
Thousands.
Well, probably not thousands, but I would easily say hundreds, okay? Easily hundreds. So it's really kind of impossible for Microsoft or Linux developers to put it into the operating system and say, okay, this is how we utilize every single possible video card, because by the time Windows is released, okay, let's say Windows 8, which is the current version, by the time Windows 8 is released, do you think NVIDIA will stop developing new chipsets? No, they keep going, right? AMD will keep going and try to develop even more, even higher performance chipsets, because they're competing. So it's not possible for an operating system to know exactly how to utilize all of these different possible peripherals. Yep, go ahead.
Would it make more sense for the manufacturer to be compliant with the operating system versus the other way
Yep,
around?
that's exactly what is going to happen, but not in the way that we think it is, okay? The hardware itself is still custom, proprietary. So what they're doing is they are conforming to a standard so that the operating system can ask the contractor to make use of that resource. So we'll get to that part, okay? You're definitely thinking in that direction, which is good. Okay. So this is analogous to having everything done by government employees, including garbage collection, power generation, and etc. All the utilities, well, do we want the government to be able to handle all of this stuff? So instead of requiring an operating system to know exactly how to utilize every single piece of hardware component, an operating system now only needs to know how to specify a driver interface. A software driver is a special collection of instructions with the following characteristics. 1, it understands the driver interface of an operating system. 2, it surfaces requests from an operating system. Okay, so this is kind of like flipped, right? Because remember, with applications, an application requests surfaces from an operating system. This is the other way around. The operating system can request surfaces, or it can send requests to a driver, a software driver. It knows how to utilize a particular hardware peripheral component, and sometimes it can also notify the operating system if there's any quote-unquote event that is of interest to the operating system. Okay, so let's go ahead and try to make this more clear.
Is that like the updates that you get on your system to say update certain applications?
No, well, sometimes the update can include updates to the software drivers, but that's not what it is. Okay, so what it is in this case, I'm using Microsoft as an example. So Microsoft can publish the standard of a video display driver interface to manufacturers like NVIDIA and AMD. Okay. So what this means is Microsoft can specify a set of standards and say, okay, when Windows wants to display something on the screen, it will do these things. It will fill in these forms. Okay, this is the standard form that the operating system will fill when it wants to display something on the screen. Okay, and that form is published. Okay, it has all these fields. Okay, what shape do you want to draw? Okay, pick one of the following. Okay, circle, rectangle, so da 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 da. Okay, what is the texture of that surface? Okay, how do we get the texture of the surface? Okay, specify the location of the bitmap of the of the texture, and so on and so forth. So there's a particular form that Microsoft says, okay, whenever Windows wants to draw something on the screen, I will give you a form that looks like this. Okay, all right, are we doing okay so far? And Microsoft is responsible to let people know what that form looks like. So in return, NVIDIA and AMD will design chipsets that are not interchangeable because they're competing companies and a lot of that stuff is proprietary. However, NVIDIA is responsible to develop drivers for their own chipsets. Now, let's take a look at this part here and find out exactly what that means. So, Microsoft has already said, okay, whenever I want to draw something on the screen, I will give you a form, and the form looks like this. It will have these fields. It will give you all this information. When I turn around and I become, NVIDIA, I have, a super duper, hardware. I'm just going to use a little prop here. Okay, this is the chipset. Okay, this is the chipset that NVIDIA is using on their video cards, and I am the driver software. Okay, so the software driver, will first look at the form that Windows is giving the driver. Okay, I look at the form. It says, okay, the operating system is asking me to display, this particular object at this location in three-dimensional space with these things as illumination. Da 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 da. Okay, so I have to do some 3D rendering. Okay, that's what the operating system is asking me to do. So I would turn around. Remember, I am the NVIDIA software driver. This is the NVIDIA chipset, the actual hardware. So I am the one who understands, okay, so to do all of these things that the operating system is asking me, I know how to do it. So I turn around and go, work on the actual hardware to make it actually happen. Okay, so what about AMD hardware? Well, AMD hardware has a different person to do the translation, another person to look at the request from the operating system and then translate the request from the operating system to actual manipulation of the hardware to accomplish the same thing. Yep?
If the operating system sets a standard and the chipset has their extra bells and whistles, how does that fit in?
If you look at it as a picture, this is, let me see if I can draw the picture real quick here. So I'm going to go to, let's see, try to find the best way to draw the picture. Okay, I can use Office Draw. Okay, so let's see, we can use boxes here. All right. So let's say this box is the operating system. Okay, this is how we can do the whole thing. And I can zoom in a little bit so we can all see better. Okay. So at the top level here, we have application. Well, actually, let me make even more space to finish this picture. I'm doing this instead on the whiteboard, so this will be a part of the screen capture too. And then we have a user here. So ultimately, we have a user who is trying to use the computer to do something. And a user doesn't usually interact with the operating system. A user is usually using an application program of some kind. So the application cannot really do a whole lot by itself. It has to interact with the operating system to manage to handle the resources. It has to request the operating system to do something, and sometimes the operating system can say, nope, cannot do that. But the operating system can only directly control core hardware resources. It cannot control the peripheral hardware resources. So in the case of hardware resources that are peripheral, you have the peripheral hardware here. So peripheral hardware sitting here, and the operating system says, I cannot possibly know how to deal with every single piece of hardware that someone can install on the computer. So to do the translation, we have a layer here called software drivers. All right. So if I want to make lines to connect these things, let me see what is the best thing to do here. Okay. So a user will interact with an application. An application can interact with an operating system. An operating system, if it is trying to deal with something that it cannot control directly, it will tell the contractor, which is a software driver, and say, hey, I want to draw this thing at this part of the screen, or I want to send this, I want to send this audio clip to the speakers. Okay, so it will tell the software driver to do that. The software driver, which is still software, it is still instructions that your processor executes, will then translate, will then use the instructions to control the actual hardware of the device that you purchased, that you hook up by USB or PCI Express or whatever.
So to control the devices, it would use the software.
The software driver, yes. The software driver directly controls the hardware that you install in your computer. Yep.
So kind of like if you're trying to build a house, peripheral hardware was like a contractor that spoke a different language, that the driver would be kind of like a translator.
The concept of a contractor in this case is the operating system doesn't need to know everything, especially things that will change really quickly, and it is out of the control of the software publisher. So Microsoft has no way to predict what NVIDIA may do next or what AMD may do next. So it's not reasonable for Microsoft to say, okay, we will take on the responsibility to deal with all the possible chipsets in the next few years. So instead, it is telling NVIDIA and AMD and say, okay, you guys have to manage your own hardware. Okay, if you make a new hardware, new chipset, new video card, you will be responsible to finish the software driver part so that the operating system doesn't need to be updated. You just need to install a new software driver to utilize new hardware that you purchase. Is that making sense?
Yeah.
Okay. So if you look at this entire picture, everything inside here, they're all considered software. So let me push this to the back. Range, send backward, send it all the way to the back, behind, send it back. There you go. So let me change the barriers, use a different color. Okay, so everything that is in the yellow box here is software. But within the software part, you can see that there are three distinct components. Application, like Microsoft Word, LibreOffice Writer, your browser, and so on. That's the application. Operating system, Windows, Linux, Mac OS X, and so on. And then software driver is basically the stuff that you install from the CD or the internet when you purchase a new graphics card, a new sound card, whatever you plug into the computer. So those are the three major components when it comes to getting your computer to work. From your perspective, which is a user, you install the peripheral hardware and you try to utilize it. But all of these things have to happen in between to make it possible.
Sorry, what was that area, the yellow area again?
The entire yellow area are this is all software. Yep. So we have the end user on the top, we have actual hardware at the bottom, and then we have software in between so that you can utilize the hardware. Okay? Now this picture also shows you the close relationship between the operating system and the software driver. Remember, the software driver needs to have a lot of access to hardware because it needs to work with the chipset, it needs to work with all the hardware that you're installing. What if there's a bug in the software driver? What if it crashes? It can take the operating system with it. Okay? And that is why Windows is quote unquote